When designing a map projection for an area that's some subset of the globe or not as big as the globe, some important things to keep in mind are the standard parallels and the central meridian. And this comes into play in this example for this conic map projection. If we think of the cone that we're overlying on the surface of the Earth, in this case it's a secant case. The cone is actually cutting through the globe along this red line here, and also cutting back through the globe along this red line here. These two would be called our standard parallels. Those are the two lines of latitude along which there will be zero distortion on the resulting map. So where the standard parallels occur is one consideration in making a map. Another consideration is what's going to be right in the middle of your map. And this is this red line here, and this is called the central meridian. So once we make the projection, we flatten out the map, there's going to be one central line from the map where it goes from curving up in this direction to curving up in this direction, and that line of longitude is called the central meridian. So in this example here, for this map of the United States, there are two lines of standard parallel. One is at 45 degrees north latitude, and the other is at 33 degrees north latitude. And then the person making this map had to decide what the central meridian would be that would cut right down through the center of this map. And as we can see, this person chose a central meridian approximately halfway between the landmass of where Maine starts up over here, around 65 degrees, and where Washington and Oregon end over here at around 125 degrees. So just by taking the longitude line of that at 95 degrees, the map looks centered and symmetric in this map projection. So this idea of a central meridian is important. And on this map projection here, this is a pretty typical map projection, I would say, where the central meridian happens to line up with the line of zero longitude, which is also called the prime meridian, which runs through Greenwich, England here. The nice thing about this sort of map projection is the place where either side of the map is, on the west side of the map here or on the east side of the map here, there's not a lot of land to cut through. So this would be like the Bering Peninsula in Russia, and here's Alaska here, and we might have to cut off a little bit of that. You can actually see this is repeated a little bit. This area here shows up again over here, but this idea of using this as a central as the meridian, the central meridian for a map, is a pretty common idea here. But if we wanted to make a nice map of the Pacific Ocean, such as here, we might choose a much different central meridian. This central meridian is located here, and it's once again designed so that most of the interruption happens through the ocean. We can see that Greenland is interrupted here, but most of the interruption happens between where North America and South America appear on one side, and Europe and Africa appear on the other side. And then we're really highlighting the Pacific Ocean, the Indian Ocean, and the other continents as well. We could also center a map on the United States if we wanted to, as in this example here. And in this case here, we're just putting the central meridian in right through the middle of the United States. And of course, the only thing to be aware of for a map like this, it might be a more appropriate map if we were just showing the central area. But because we're showing Africa and Europe and Asia as well, we can see that Asia really gets cut down the middle here. The continent is divided on both sides of the map, and sometimes that can confuse people a little if depending on how used they are to looking at maps like this. Another way that we can consider the central meridian, and also these kind of what we call lines of intersection. We no longer call them standard parallels because parallels are latitude and these are not lines of latitude. They're also not lines of longitude, but they're the same idea. It's where the cylinder would intersect the globe along two different lines, which are shown as dashed red lines here. And then the red line in the middle, the solid red line, is still called the central meridian, but we no longer call these two lines standard parallels, or we don't call them standard lines of longitude either, because as we can see over here, they don't exactly follow the lines of longitude. They're going to vary moving away from the equator in either direction. So we just call these lines of intersection, but once again, the same idea. These two red dashed lines are going to be lines of no distortion, so we want to carefully think about where we want to put those, and the central meridian, once again, is just going to determine what we have in the middle of our map. So with these examples here, UTM is a good example of one that uses this sort of map projection. And with these UTMs, we can see that here the central meridian is placed through here, and this shows the zone boundaries on either side, and those will be close to the lines of zero distortion, which would now be running north-south, both here in the northern hemisphere for zone 11 and in the southern hemisphere for zone 52. This would be the central meridian right down the middle, and the lines of zero distortion would approximately follow these two boundary lines on either side.